Welcome to a technical tour of BERT and its powerful variants, where we explore architectures, optimizations, and strategic applications. The slide shows a neural diagram and a bar chart comparing BERT, Robert Actura, Distilbert, and Albert, giving a quick sense of scale and capability. Over the next slides, we will unpack what distinguishes each variant and why those differences matter in practice. Here we compare BERT Base and BERT Large to highlight trade-offs between speed and representation power. The diagram contrasts a 12-layer base model with a deeper 24-layer large model, and the bar chart shows roughly 110 million versus 340 million parameters. In short, larger models offer richer representations at higher compute and memory cost, which guides deployment choices depending on constraints. Distilbert compresses knowledge from a full BERT teacher into a smaller student model through knowledge distillation, preserving much of the semantic power while reducing resources. The visuals show the teacher-student flow and metrics, indicating about 97% accuracy retention, with around 40% fewer parameters, and notably faster inference, making it a practical choice for real-time or resource-limited applications. TinyBERT takes compression further, with a two-stage distillation tailored for edge deployment, first learning general representations and then refining task-specific knowledge. The flowchart shows transfer of attention weights and embeddings to a tiny student model, achieving dramatic size reduction and large inference speedups, which enables efficient on-device NLP for mobile and IoT scenarios without severe accuracy loss. Albert focuses on parameter efficiency through shared layer weights and a factorized embedding matrix, effectively decoupling vocabulary size from hidden dimensions. The diagram shows how weight sharing cuts memory footprint while maintaining competitive accuracy, enabling feasible training with larger batches and longer sequences for organizations with limited resources. The result is a model that scales pre-training more efficiently than typical large variants. Robert refines pre-training and architecture choices to push BERT's limits by removing next sentence prediction, employing dynamic masking, and scaling up data, batch sizes, and sequence lengths. The slide illustrates these training enhancements and their measurable impact, showing superior glue and squad scores compared with the original BERT, which highlights the importance of careful hyperparameter tuning and more extensive pre-training. Electra introduces a replaced token detection objective that is more sample efficient than masked language modeling. The training diagram shows a generator corrupting tokens and a discriminator detecting replaced tokens, which uses all input positions during pre-training. This approach reduces compute, accelerates pre-training, and still yields strong downstream performance, making it an attractive strategy for faster model development with lower resource demands. XLNet combines autoregressive and autoencoding strengths through permutation language modeling and integrates Transformer XL for long-range dependencies. The schematic shows tokens predicted in varied orders to capture bidirectional context without traditional masking, which improves sentence structure and coherence modeling. In practice, XLNet often outperforms BERT on deep understanding tasks and better handles longer dependency structures. Domain-specific BERT variants like BioBERT, SciBERT, and Clinical BERT are created by continued pre-training on specialized corpora, such as PubMed abstracts, semantic scholar articles, or clinical notes. The slide highlights gains on named entity recognition, relation extraction, and question answering in technical domains, showing that embedding domain vocabulary and context yields significant performance advantages over generic BERT for specialized tasks. Multilingual and language-specific variants address cross-lingual and language-tailored needs. Models like MBERT and XLM train on over 100 languages to enable zero-shot transfer and cross-lingual representations, while Chinese BERT and Sino-BERT incorporate idioms and segment-aware tokenization to improve sentiment analysis, news classification, and idiom understanding. The visuals emphasize both global transfer capabilities and targeted language optimizations. Strategic model selection matches variant strengths to deployment constraints, recommending lightweight options like DistillBERT and TinyBERT for edge and mobile, Albert for low-memory environments, Robert or Electra when maximum accuracy matters, and domain or multilingual models for specialized or mixed language data. The emphasis is on balancing latency, memory, dataset size, and task complexity to maximize return on investment for a given application. Looking ahead, research emphasizes greener compression, instruction-tuned variants, retrieval, augmented integration, and continual pre-training to support evolving domains. Future models are expected to be smaller and faster, offer multimodal versatility and reduced latency, and adapt dynamically to new vocabularies and tasks without full retraining. These trends point toward more efficient, adaptable models for a wider range of real-world deployments.